Okay, this is lesson 3.3. We're on page 8. 3.3, which is application. So we've learned how to solve problems now. Ms. Miriam, why would we ever need this in the real world? It's a great question. I'm so glad you asked that. Today is going to be an example of where and why you would ever use this in the real world. Beyond the fact that you probably will never have an n plus 10 equals 20 in your day-to-day life, you will use critical thinking skills. And so that's what this lesson is working on, is critical thinking skills. I also know, for most of you, word problems have been a negative thing in the past. You freak out when you see them, you skip them on a test. My goal for you is that I help you figure out what to do when you see a word problem so that you can at least get some partial credit, okay? And that you don't freak out. All right, let's look at these steps. Step number 1 is, what are you trying to find? That's what we need to figure out. What are you trying to find? Use a let statement to define a variable. What does that mean? That means if I put a variable up there, I need you to tell me what that variable is standing for. Okay. Second thing is to set up an equation, which yesterday, remember, we worked on translating things like a number increased by 5, right? So we learned a couple of those things. And then give an exact answer for what the problem is asking for. So we're going to do a bunch of these together so that you feel comfortable to do these on your own. All right. Number 1, would anyone like to read number 1 aloud? David?
Ashley's tomato plant grew 9 inches over the summer. Her plant is now 23 inches tall. How tall was it at the beginning of the summer?
Okay. Ashley's tomato plant grew 9 inches. What does growing do? Are we adding things or are we taking things away when we grow? We're adding things, okay? So we know that this grew right here. We know we're going to be adding 9. We're going to add 9 to something. Does anyone see the equals word in the story problem? What word did we say means equals? Is. Does anyone see the is in the equation or in the words? It is what? It is 23, right? So I know that something has to equal 23. So I can go ahead and put that down. That's the easy part, is to figure out what does it equal. So I know something has to equal 23. It says, how tall was it at the beginning of the summer? Guys, here's the hint. When it says, how tall was it at the beginning of the summer? That's what we're trying to find, right? That means that's what our variable has to stand for. If that's what we're trying to find, that's what our variable needs to be. So we can say, let x equal height at the beginning, and you can abbreviate, of summer. Or whatever variable you want to use. Let x equal the height at the beginning of the summer. So if we take the height at the beginning of the summer, what are we going to do to it to get to 23? Multiply. Is there anything up there that says multiplication? Did we take care of this guy? That 9 inches? To figure out the answer, we're going to have to subtract. But if I take x, which is the height at the beginning of the summer, and I add 9, which is what it grew over the summer, that should give me 23, correct? Again, if this is new to you and you're thinking, Miriam, I would have never come up with that on my own. It's okay. That's why we're practicing. Okay, so if I wanted to solve x plus 9 equals 23, if I want to solve x plus 9 equals 23, and I'm going to write it off here to the left. Remember, your x is here, which means we need to get rid of what? Christina, what do we need to get rid of? 9. How are you going to get rid of that 9? Good, subtract it. Why did you know that you needed to subtract it? Excellent. Because the 9 is already positive, so to get rid of it, we have to subtract 9 on each side. X equals, what is 23 minus 9? 14. So that's my solution.
Well, I didn't have to do all that, but I got 14.
So here's the thing. You just did some subtraction in your head, right? But if you don't understand the process of how to actually write the equation, then you're going to be stuck when things take it up a notch. Okay? But what does 14 mean in this problem?
14 inches.
14 inches, right? X was the height at the beginning of the summer. So we need to say this is 14 inches. So if I asked you to write it in a sentence as to what happened, you could say the plant grew 14 inches over the summer. All right, questions on number 1. All right, number 2. Who would like to read number 2?
3 sodas cost $4.95. What is the cost of each soda?
Okay, so of one soda, which each soda is the same thing, right? All right, so what is the cost of one soda? Remember we said this part right here tells you what you should be doing. So if we use our variable, we could say X equals cost of what? One soda. We're on page 8. So X is going to be the cost of one soda. Okay, remember I said the easiest thing to find when you're doing an equation is to find out what it equals. So what does this problem equal? What did you say, Mandy? 495. So we know that 495 is going to be my total and my equal, so I can equal 4.95. And again, guys, even to get that part of your equation, you're going to get partial credit. All right, so even doing part of this, you get partial credit. So if this is all you can do on your test, you're still going to get points. You defined the variable, you got part of the equation right? All right, so when you see a word problem on your test or in your homework, don't just give up. You get partial credit. Where did that go?
It disappeared.
Oh, no. I got it. Okay. You're going to get partial credit on your test, okay? All right, 3 sodas cost $4.95. Do we know how much each soda is? Okay, do you know how much each soda is off the top of your head? No. The answer is no, we don't. Terry's already done some math. He's working ahead. Okay, but we do know that there are how many sodas? 3. Are we going to, if we knew that, say we knew that the cost of each soda was $1, how would we do to get the total? What would we do to get the total? If we knew they were each $1 and we had 3 sodas, what would you do? Multiply 1 times 3, right? But we don't know how much each soda costs. So we know that we're going to take 3 and multiply it times whatever our sodas cost. We don't know what they cost right now. And if we weren't sure whether we were supposed to subtract or divide or multiply or whatever, think about what I just did. I put an example in, and this is a tactic to solve story problems. I put an example in of, okay, if they were $1, how would I get the answer? I would do 3 times 1. So I knew I needed to multiply. All right? Again, I'm not asking you to come up with this on your own. For most of you, this is brand new, which is why I'm teaching you how to do these things. All right, so if my problem is 3x equals 495, we know that that's multiplication. So how do we get the x by itself? Everyone should be saying that if you were here yesterday. We should divide each side by 3. 495 divided by 3, you can use a calculator for this. 495 divided by 3, someone check Terry's math. He said $1.65. Is Terry correct? $1.65, is that what we're getting?
Mm-hmm.
Okay. So x equals 165 per soda. That's fine. I won't count off if you don't put the dollar sign. But it's $1.65 per soda. Any questions on number 2? Okay. Number 3. Who'd like to read number 3? Mandy?
Maggie spent half of the money in her savings account on a new computer. If the computer was $345, how much money was in her savings account?
All right, so if we're going to define our variable, remember our variable is whatever they tell us at the end. How much money was in her savings account? So we'll say X is the money in the account. So what else do I know in this problem? What else do we know in this problem? Mackenzie? Okay, she spent half of the money in her account. All right. Let's find, remember the second thing I said to find is what it equals. What does this equal? 345, right? We knew that that was the total that was in her account. By the way, was is a form of is. It's just past tense, right? Here's another hint. As you're doing word problems, cross stuff out after you get done with it. All right, we already know that that's happening. I think sometimes being able to cross stuff off, first of all, is satisfying because you get to scribble stuff out. But also, it makes the problem less intimidating because now we don't have as many words. Okay, Mackenzie said Maggie spent half of the money. So we know we have 1/2 of something. Of, in math, that word of means times. Of means times, or however you want to write that. Of in math means times. So if you have 1/2 times, it says the money in her account. Well, what did we just say represented the money in her account? X. So if you have 1/2 times the money in her account, what's that going to look like? 1/2, what? X. 1/2 X. Now, we haven't had a lot of fractions when we're solving these. To get rid of a fraction, to solve this one out, to get rid of the fraction, if this was your equation, 1/2 X equals 345, you can multiply by what's called the reciprocal. When you have a fraction, you can multiply by the reciprocal. When you do that, you make this number just become a 1, which is what we wanted, meaning X is by itself. But whatever you do on one side, you have to what? Do on the other side. So we're going to multiply this side by 2. And if you multiply it by 2 over 1, it's not going to change. So we can just multiply it by 2. So take a minute and do your old school multiplication. 345 times 2. Do that real quick. Hang on. April, what'd you get for X when you multiplied by 2? $690. Anybody else get that? Okay. So we know X equals $690 in her account. And I need some kind of words or description after each answer. Don't just tell me what X equals. Give me some kind of description like we've done in the last 3 problems.
Well, I got that one later on, so how is that possible?
I don't know. Did you multiply by 2? Okay.
No, I took away.
So it's not being added. Look, this is not being added, so you can't subtract.
No, but if you take 345 away from the count.
Away from what?
from her account.
But you don't know how much was in her account. So you can't take 345 away from anything because you don't know how much was in her account to start with. That's what we were trying to find. We'll keep working on them. All right, who'd like to read number 4? April?
A shark descended 32.6 feet to catch a fish. The shark is now at negative 82.25 feet. What was his starting point?
Okay. What is our x going to be?
Starting point.
X is the starting point. All right? So we're going to write that. X is the starting point. Remember, you have to do this part. X is the starting point. You have to tell me what your variable stands for. Okay? So we got that part taken care of. What is our total? What's going to be on the other side of the equal sign?
Negative 82.25.
Is the negative 82.25 the total that we're at now? Or is it the 32.6? What do you guys think? Which one is our total? The negative 82. Okay? So we know that goes on the other side of our equal sign. All right, so we have taken care of that. So we're going to cross that out. If the shark descended, what does that mean we're doing? We're going down, right? If you descend, that means you're going down. So we know that we have to subtract 32.6 from something. That's what that descended 32.6. So would it make sense that I have to subtract 32.6 from my starting point? Would that make sense? Do you take it from your starting point? And what did we say our starting point was? What did we say our starting point was?
32.
Nope. X, right? So we're going to have our X minus 32.6. X minus 32.6 equals negative 82.5. All right, so if I try to solve this, X minus 32.6 equals negative 82.25. Think about where your X is. How do we get rid of this negative 32.6? Put another one under it, but what operation are you doing? Are you adding it? Are you multiplying it? Are you dividing it? What should we do here? Why should we add it? Because it's being subtracted, right? And so we always do the opposite. So I'm going to add 32.6 to both sides. And you can draw your line if you need to. Yep. If you haven't worked with decimals in a while, they should always line up. Now, let's talk about this for a minute. I have a negative and a positive, and when I have opposite signs, what are we supposed to do with them? You're actually supposed to subtract, right? So I can put a 0 here, and if I subtract, that gives me 5 minus 0 is 5. What do I have to do with that 2 to subtract 6? I make it a 12, right? Which makes that an 11. 12 minus 6 is 6. And then we have to borrow again, right? 11 minus 2 is 9. 7 minus 3 is 4. Is this a positive 49.65 or a negative, Ashley? A positive 49.65 or a negative 49.6? Why is it negative? Which one is bigger?
Oh, shoot. It's a negative.
It is a negative because the negative 82 is bigger. So that means the shark started at negative 49.65 feet. So we'll say x equals negative 49.65 feet. Whew. Take a deep breath. You guys are doing great. All right, who wants to read number 5?
There are 14 students in an art class. Mr. Travis has 350 colored pencils to distribute equally among the students. How many colored pencils will each student receive?
Okay. So how many colored pencils will each student receive? So that is our variable, right? X equals number of colored pencils. So now we can cross that part off. Do we have a total of something? What do we have a total of? 350, right? So we know that's going to be our equals. Something has to equal 350. Okay, so if I told you that every student got 2 colored pencils, okay, let's just take this for an example because now maybe we're not sure what we need to do. If every student got 2 colored pencils and there are 14 students, how would we figure out how many colored pencils there were? 2 times the 14. Is that what you guys are going to say? Okay. We would multiply 2 colored pencils times the 14. But do we know how many colored pencils they each got? What did we use to say that? We used our X, right, to say how many they got. So remember we said times, right? So what is going to be on the left side of the equation here? 14 what? 14x is going to be on the other side. Yes, ma'am.
But when we divide it, since you're giving them out.
That's exactly what we're going to do, right? That's the process of doing that. So you got to think the step right before that.
How does that distribute and multiply?
Distribute just means to hand out. You're right. You got to kind of think about what that says. Usually distribution means to multiply, which would have been a big hint, right? Distribute means we needed to be multiplying something. And isn't that what we're doing when we smash 14 and x together? Okay. Good observation. We're on page 8, Zaria. All right, 14x equals 350. How do we solve 14x equals 350? Divide, right? X to get it by itself, I have to get that 14 off there. So I'm going to divide each side by 14. Use your multiplication sheet. 350 divided by 14. 25? Is that what you guys are saying? 25? So what does 25 mean? 25 what? 25 pencils. Every student got 25 pencils. Okay? So we would say x equals 25 pencils. Okay. I would like for you to try to set up number 6, and I'll come in and help you. Okay, but you at least know how to get it started, and you know how to get a total. Okay, did we make some progress? There shouldn't be any blanks on your papers because you know how to do the first 2 steps. You know how to do let x equal something, and you know how to find a total. X is the what? Not Melissa make. X. How many did she make? So X is the what? The number that she made, right? The number of cupcakes. Okay, so we know that X is the number of cupcakes. From Melissa, right? That's how many Melissa made. So you could also say Melissa's cupcakes or something like that. What's our total going to be, Jose? What'd you put on the other side of your equal sign? Number 6.
This is took 12 times 6 plus 88.
Okay, so what you're doing is you're not setting up an equation. And I appreciate the fact that you knew exactly what you needed to do, but if we don't work on setting up an equation, then as things get a little bit harder.
I took the baker's dozen and it said made 6 dozen.
Do you have an equation where you have X and something equals something else? Okay, that's what we need to work on. Okay, so I need you to stay with us. What's on the other side of the equal sign? 88. All right, so if you've gotten this far, you at least are getting some points to be able to start something, right? Now, 6 dozen more cupcakes. More means we're going to be doing what? You're going to be adding. If I have 5 more than you, are you multiplying by 5? Or are you adding 5? You're adding 5, okay? So 6 dozen more cupcakes than Melissa. We don't know how many cupcakes Melissa made, but we called it what? X, okay? So we got our X and we're adding 6 dozen more. And 6 dozen, Jose was reminding us, is 6 times what? What's a dozen? 6 times 12 is not 36. 6 times 12 is 72. Use your multiplication sheets, please. 6 times 12 is 72. So we're adding 72. If you don't write an equation, you will lose points. If you just solve it out and get the answer, you'll get some points for that. But the purpose of this lesson is to be able to write an equation. Okay? If X plus 72 equals 88 is our equation, what do we do to solve that? Chelsea, what's the first thing you did?
Find a variable,
Okay?
and then put negative 72 underneath.
So we're subtracting 72 from each side, right? So I get X equals 16. So that's 16 cupcakes that Melissa made. So by M. 16 cupcakes by M, that's how many Melissa made.
I had 16, I didn't have none of that.
Okay, that's why we're doing this. So we've done 6 problems now where we've set up an equation. And if you're following the process that I'm asking you to do each time, you should at least be able to get partial credit. Okay, we're going to skip number 7. Let's go to number 8. I want you to try to set up number 8. So those of you who have skipped ahead and not paid attention, you need to make sure you are setting a variable and finding the equals. You can do those 2 things. Snow is falling at a rate of 2.5 inches per hour. At this rate, how long will it take 8 inches of snow to fall? Okay, so X is going to be the number of hours or the time, whichever one you want to put, number of hours or the time. What's our total going to be in this one, Becky? What's your total number? 8. Okay, so if you have something equals 8, you're getting partial credit already. 2.5 inches per hour. Do we know how many hours this was happening? No, we called it what?
X.
We called it X because that's how many hours. But we do know that it's 2.5 per, and David asked how many, what does per mean? Per means times. So how do you represent 2.5 per hour? And we said hour was represented by our X variable. So maybe I should say that this is times. Also, if you're making a note like this, on your notes, when you go back and you see the word of or you see the word per, you'll be able to look back at your notes and say, oh yeah, that's what that word meant, times.
But per hour, that would be 8 hours.
Not 8 hours. We don't know how many hours it's going to take to get 8 inches. X times 2.5? So if we have X times 2.5, that's correct. But how do we usually see that when we have a variable?
2.5x.
2.5x, right? Still the same thing, okay? So we usually will see it as 2.5x, okay? So this is your equation, 2.5x equals 8. If we want to solve this, 2.5x equals 8, what do we need to do to get x by itself? It's being multiplied, right? And what's the opposite of multiplication? Divide. So I'm going to divide by 2.5, and I'm going to divide by 2.5. Eight divided by 2.5. You can use your calculator if you need to real quick because it's decimals. We know 2 and 2 hours is 4. 5 hours. I think it's going to give us a decimal. 3.2. 3.2 what? What is X standing for? 3.2 inches or 3.2 hours?
Hours.
So we would say X equals 3.2 hours.
That same as 3.5.
Is 0.2 of an hour, 0.2 of an hour, is that half an hour? No, it's 12 minutes. Okay, questions about that part? Okay. There's a whole nother page of problems. We're not going to do all of these. Let's see if you can do number 9. Number 9 is like one that we've already done. Okay? So I'd like for you to try number 9, please. Okay, so what was the cost of one movie ticket? We know that's our X. Cost of one ticket. So I can cross that out. A total of $67.50. Who got this far on their paper? You at least got this far. Okay, so you're getting partial credit. All right. And if I have 6 people, do I know how much one movie ticket costs? I think we understand. Would you guys agree that if you just read this without trying to figure out what the equation was, you would want to divide $67.50 by 6, right? Like that's kind of your gut reaction to do that. Yeah. So to think about what's the step right before that. If you need to divide by $67.50, then that means your equation should start as multiplication, as the opposite, okay? So if you're in your brain, I think it's intuitive, we think, well, we need to divide that by 6, okay? So if you're thinking that, that's awesome. That means you're getting it, okay? But then think about the step right before that would mean you need to multiply 6x so that you can be able to divide by 6. Does that make sense a little bit? Yeah. Think about the step that has to happen right before that. Because if our equation looks like this, 6x equals 67.50, if we want to get x by itself, we're going to have to divide, which is what you wanted to do anyway, right? So then the step right before that would mean you'd have to have a multiplication problem, okay? And what are we getting each ticket to be? $11.25 per ticket. Awesome. Okay, let's do one more and then we'll have some work time. Which one do we want to do on this page? One more. Let's see. Ricardo bought number 14. Ricardo bought $46.23 worth of groceries and paid with a $100 bill. How much change did he receive? So thinking about on this one, think about what you automatically want to do in your brain, and then think about what the step has to be right before that in order to do what you want to do in your brain. And our instinct is to do what? 100 subtract, right? That's our instinct. Would you guys agree with that?
Yeah.
That's your instinct. And so if you want to subtract, what's the step right before that has to happen? You have to add something, right? So if we took the change we receive and we added the cost of the bill, that should give me my $100. So if this was your automatic, I think I need to do this, 100 minus 46.23. We want to subtract, which is correct. But in order to subtract, I have to start with an addition problem. Okay, so that's why we started with an addition problem. X plus 46.23 equals 100. So if I have X plus 46.23 equals 100, to get X by itself, indeed, we do need to subtract from both sides. What do you get when you subtract 46.23? You guys can use your calculator if you need to. 53 what? 53.77. Is anyone else getting 53.77? Okay, let's do some math over here. $53.77. So X equals 53.77 in our change.
So the calculator says
You put 63. 42.63 instead of 46.23. You flip the numbers around. All right. For your assignment, I'd like you to turn to page 10, please. And I want you to work on all 10 of these, okay? I want you to try all 10 of these on page 10.